Hello everyone and welcome back. Now for something bright, a retrofitted antique looking oil lamp with 4 LEDs that are turned on and off in a chaser pattern to provide the appearance of flickering fire. The ATTINY13A driving 4 SMD LEDs linked to each of its 4 IO pins form the heart of this project custom circuit, which is powered by a CR2032 coin cell. A traditional oil lantern was chosen for this project, and the oil lamp feature was to be replaced with an electrically glow in the dark circuit that wouldn't run out of oil. This video is about the whole build process of this lantern, so let's get started with the build. Here's a schematic that was created which include an ATTINY13A connected to 4 LEDs, with each LED's anode connected to the IO pin of ATTINY13A, and each LED's cathode is connected to a resistance in series with ground. The load resistance is a crucial component of this circuit that will control the amount of current flowing through each LED. A CR2032 coin cell battery is used as the power source, and between the battery's positive and the ATTINY's VCC, there's an on and off switch. The Gerber data of the PCB was then exported after the PCB file was completed, and the Gerber data was then sent to PCB wafer samples. An order was placed for the PCB with yellow solder mask with white cell screen, as they look pretty cool in general. The PCBs were received within a week and they were excellent as expected. As a leading China PCB manufacturer, PCBWay offer one-stop PCB manufacturing services, ranging from raw material and electronic component procurement and in-house PCB fabrication to PCB assembly, testing and shipping. They even have 3D printing services. Check out PCBWay for getting all kind of PCB related services at a lower cost. We begin the board assembly by applying solder paste to each component pad individually using a solder paste dispensing syringe. Next, we pick and place all the components in their proper place using ESD tweezer. Following the pick and place process, we place this board on a mini reflow hot plate, which heats the PCB from the bottom side to the solder paste melting temperature. Now we add the switch in its place and solder its pad using a soldering iron. Next, on the bottom side, we add CR2032 coin cell holder to its location and solder its pad from the top side of the board. Here's the code that I've used in this build. This code set up 4 LEDs connected to pin 0, 1, 2 and 3 on the ATTINY board and control them in a chasing pattern, first moving to the right and then to the left. The LED stays for 50 milliseconds and then turn off before moving to the next LED in the pattern. We have designed a cylindrical PCB holder that lifts the PCB and keep it inside the top glass body of the lantern in order to hold this circuit inside the body of the lantern. The red PLA was used with a layer height of 0.2 mm and a 0.4 mm nozzle to print this part, which was created in Fusion 360 and exported as an STL file for 3D printing. To install the circuit on this 3D printed part, we need two M2 screws. Ultimately, we assemble the lamp by only placing the top glass portion on the top of the metal lamp frame and the PCB holder assembly section. This project is finished and now we have a vintage oil light that employs modern tech. Overall, I am pretty satisfied with the outcome, and my dining room now features a stunning lamp. Well, this is it for today folks. Please leave a comment or DM me if you need any help regarding this project. If you made it this far, thanks a bunch. Special thanks to PCBWay for supporting this project. Do check them out for getting great PCB service at a low cost. Thanks again, and I'll be back with a new project pretty soon. Peace out.